On page 320 comes the idea, what if you have 3 times the square root of 2 plus 5 times the square root of 2? Then those are just like radicals, aren't they? Wouldn't this be, what if it was 3x plus 5x? What would it be? 8x. So what if it's 3 square root of 2's and 5 square root of 2's? They're exactly alike, aren't they? So what would you have? 8 square root of 2. Okay? What if it had been, instead of that, what if it had been 3 square root of 2 plus 5 square root of 3? Now, they're not like, are they? So you can't combine those together. You can't simplify those. What if it's a problem like 3 square root of 2 plus 5 cube root of 2? A square root and a cube root. What would you say? They're not alike, so you can't combine them together. Don't dare combine anything together that's not alike. And then what would happen if you had something like 3 square root of 2 plus 5 square root of 8? You might say, well, they're not alike, so you can't combine them together. But before you jump to that conclusion, there's something different about this problem. Do you notice what it is? The square root of 8. You can simplify the square root of 8, can't you? You can simplify the square root of 8, and you could call that the square root of 4 times the square root of 2, couldn't you? Now, what do I get for the result of this problem? I'll have 3 square root of 2 plus 5 times... Now, tell me, what's the square root of 4? 2. And what's the square root of 2? Nobody really seems to know. Unless you look in the calculator or look at a table, or unless you have that number memorized. By the way, back in the old days, we had to memorize this. We had to memorize the square root of 2, the square root of 3, the square root of 4, 5, and the square root of 6. Because those are the most common square roots. And my teacher felt that if you knew those 4 numbers, you could probably get most of the rest of them. So anyway, but now we're not in those days anymore. We don't have to memorize these numbers. The square root of 2, we'll just leave it as the square root of 2. Okay? Now, can you simplify this expression? What would that be? 3 square root of 2, and then plus what? 10 times the square root of 2. And 3 square root of 2 plus 10 square root of 2 would be 13 square root of 2. You see? So sometimes you can simplify the radical and then combine like terms. Okay? Now that's what I want to do over on the next page. And you'll eventually build into this. When you're doing the homework, you're not supposed to just start out with a big, long problem like I'm going to ask you to do right here. But because you got me with you, I think I'll jump right into number 29 and try to show you how to find your way through a longer problem. And I'd like to start with number 29, and this is on page 321. All right, number 29, it says 3 square root of 75, and then it says minus 4 square root of 48. Plus, thank you. All right. And then minus 6 square root of 3. Let me get a different color there for that last one. I'm running out of colors. 6 times the square root of 3. Okay? So I've got 3 different square roots there. Now the first step is to simplify each of the square roots. And you notice the way I have it organized. I have 2 square roots right here, and I have 2 square roots right here. So you'll be able to break down the 75. Now what perfect square goes into 75? 25, right? 25. And what's the leftover number? 3. Got that? All right, how about 48? What's the perfect square?
16.
Somebody might say 4, and somebody else might say 16. Who should we use here? The larger one, 16. So we'll put the 16 down there, and then what's the other number? 3. And how would you get that 3 if you weren't sure of it? With your calculator, how could you get the 3? Once you see 16 goes into 48, take 48 divided by 16 equals 3, right? Use a calculator to help you out with that. All right, now I want to come back and do my first full step. Now my first full step, I want to bring down the 3. You see where that comes down? And I've got 3. So it's given there in the book. The 3 is brought down for you. Now the next thing is going to be the square root of 25, and there's a blank space for you. Guess what we're going to put on that blank space? 5. Okay, so put 5 on the blank space. If you haven't already done that, put 5. And then what else is going to go after that? Square root of 3. Okay? And now for the second part of the problem, starting into the yellow part, we're going to have here plus. We're going to have to bring down the 4, right? Which is brought down 4. You see this 4 comes down, and it's going to be right there, 4. And then we're going to have the square root of 16.
8.
Careful now, the square root of 16 is 4. And then we're going to have to bring down the square root of 3, which is just the square root of 3. Okay? So it's going to be the square root of 3. Okay? And then for the last part down here, we'll just bring down what's up here. This 6 square root of 3 doesn't simplify, so that would just be bring down the 6 square root of 3. Okay? Now, let's clean it up a little bit. This is going to be 3 times 5 would be 15. Okay, you can put that down, can't you? 15 what? Square root of 3. And then what comes next?
Plus 16.
Plus 16. Square root of 3. Okay?
Minus 6.
And then minus 6 times the square root of 3. Now, they're all square root of 3's, aren't they? They're all square root of 3's. So, can you add those together? 15 and 16 would be 31 square root of 3. Minus 6, 31 minus 6, 31 take away 6 would be 25. All right, that would be 25. So in other words, it's 25 times the square root of 3, and that's the simplified answer. Okay? Any question on that? All right, now I think this would be a good time for you to try number 30. So I'm going to stop and ask you to do number 30. Let me write it on the board in case anybody is doing this with the videotape. Oh, I shouldn't have erased that, should I? That's your sample problem. Sorry. Well, number 30, it says. Number 30, the problem says 3 times the square root of 20. And then it says minus 8 square root of 125. And then plus 6 square root of 45. Okay? We've got to separate the square root of 20 into what? Square root of 4 times the square root of 5. We'll separate the square root of 125 into the square root of 25 times the square root of 5. And we'll separate the square root of 45 into the square root of 9 times the square root of 5. Now, bring it all down. We've got a 3 that comes down. We've got the square root of 4 is 2. We've got the square root of 5. We've got negative 8 comes down. We've got 5. We've got the square root of 5. We bring down the 6, and we've got a 3 times the square root of 5. Okay? Now that would give you 6 times the square root of 5 minus 40 square root of 5 plus 18 square root of 5. They're all square root of 5s. So let's combine the 6 and the 18, which would be 24 square root of 5 minus 40 square root of 5. And that would be a total of negative 16 square root of 5. Okay? Yes? On the next page. On the next page. I need to look at a problem involving products. I want you to notice also that at the bottom of page 321 and page 322, it becomes like a tractor pull. These problems become very difficult. And then in the style of my book, I would like to go from something, when it gets as difficult as it needs to be, into something very simple. And the very simple topic that I want to look at is at the top of page 323. Page 323, I want to give you this thought. What if you have a square root, number 44, the square root of 7 times the square root of 5? How do you do the square root of 7 times the square root of 5? Well, we go from something incredibly difficult to something that's obviously easy. What would you do with that? Square root of 35, right? Boy, that was tough. Now, but it's not going to stay like that, is it? You're probably waiting for the other shoe to fall. And it falls in problem number 48. Skip on down to number 48 where it says the square root of 35 times